Good morning. Sure if that's your microphone that has a buzz or mine. Oop, went away.
Interesting. May have just been in the quiet. You can start getting a little feedback. Good afternoon, everyone. We will be starting in just a couple of minutes here. Thank you for joining us today.
Well, good afternoon, everyone. I'm Ryan Siegel. I'm joined this afternoon by my colleague Sean Maurer. I want to thank everyone for joining us today. Looking at the Commercial Energy Code for the Illinois Energy Conservation Code, specifically for plan review and inspection key items. Today's session should last approximately 1 hour. For those of you who may have any questions throughout the presentation, please go ahead and use the question and answer pane. This may be found by hovering your mouse either towards the top if you do use the chat box,
It cut
we
out
may
there,
or may
Ryan,
not see them.
just so you know.
Uh,
You cut out there right when you were saying if you hover over the top of your screen or the bottom of your screen, the control
Okay.
window should pop up.
Yep. So yes, at the top or bottom of your screen, you will find the question and answer function. So please go ahead if you have any questions, do go ahead and use that. So if you place those in the chat function, we may or may not see those. So today's session is being recorded. And that recording, along with a PDF of today's presentation, may be found at our website, sedac.org/energy-code. Certificates of participation will be available and will be sent to participants of today's session. So if you do need those, they will be provided after today's presentation. So speaking of certificates, on the next screen here, if you are an ICC or AIA member, and need those continuing education credits when we provide your certificate of participation, please go ahead and reply back with your member number, and we will go ahead and get those recorded for you. So as far as what we're looking at covering today, particularly plan review and site inspection, uh, with a focus on commercial envelopes and understanding our documentation process that can help in plan review and inspection to help speed that along for you. So a little about who we are. SEDAC, or the Smart Energy Design Assistance Center. We're housed at the University of Illinois at Urbana-Champaign. We're also part of a public-private partnership with 360 Energy Group out of this, Chicago. And our primary mission is to reduce the energy footprint of the state of Illinois and beyond. Uh, and so today's training is part of how we do that as far as providing assistance with the energy code. Uh, the Energy Code Training Program is sponsored in part by the Illinois State Energy Office, housed at the Illinois Environmental Protection Agency, and we do want to thank them for their sponsorship of this program. We do have a technical support assistance line. So if you do have questions regarding the Illinois Energy Code, feel free to reach out to us, energycode@sedac.org. So that's available for building owners, occupants, engineers, design professionals, and code officials, along with anyone else who may be involved with projects here in the state of Illinois. We also do have an 800 number if you need to reach us that way. We also have several online resources. Here again is our website, sedac.org/energy-code. Some of those resources include archives of our workshops and webinars, along with several online on-demand training modules. These are designed to take approximately an hour to an hour and a half for each module to complete, and are designed with a more a beginner level audience involved. So it doesn't take substantial code knowledge to be successful and find these trainings beneficial. So again, with some of the noted, we have our workshops and webinars along with our technical support, along with several other resources, some of our frequently asked questions, along with some websites. Some of these also include things such as links to the International Energy Conservation Code, the Illinois amendments, along with the City of Chicago amendments. So we do like to call out and note that the International Code Council does make all of their codes available for viewing online at no cost. And these also do have a very robust search function. So if you do have some, you are looking for a particular topic, you can go ahead and head over to their website and use the search function. And it may be able to direct you quickly to what you're needing. So today's session is part of a series of webinars, and here's some of our upcoming ones, including ones in February, March, and May. Our next one in February is looking at lessons learned, and will include some code officials on that webinar as well. So a good opportunity for Q&A and also to learn how others handle this process as well. So looking at when is the Illinois Energy Conservation Code triggered? And so one of these that typically is the trigger is if a building permit application is required. In the event that a building permit application is required, then that modification will likely need to comply with the Illinois Energy Conservation Code. The International Building Code, which is in use by most jurisdictions around the state of Illinois, lists several several types of work that are exempt from permit applications typically. However, please go ahead and check with your local jurisdiction, whether that's a municipality or county, and they can provide you some further guidance because they may have exempted some additional items that is beyond what the International Building Code calls for. They also may require permits for some of these things that are exempted by the model code. Uh, so as far as looking at if you have a commercial building, uh, the nice thing is the definition of a commercial building is fairly straightforward in that it is a building defined as not a residential building. Residential building does have an Illinois specific definition, uh, which is a detached one or two family dwelling, along with multiple dwellings units in a uh, single building that are 3 stories or less in height above grade, or 4 stories or less in the city of Chicago, in which the residents reside predominantly on a permanent basis. And again, the Illinois Code provides several example buildings that qualify as residential. Commercial building is everything else. So that's commercial, industrial, uh, and the like. So as far as the applicable codes, we find it's useful. Many jurisdictions do have some forms like this uh, that may be useful as far as the permitting application process. Here's some examples from North Carolina. Uh, and so you may check with your local jurisdiction to see if they have something like this either as part of the permit process or as supplement to the permit process, which may allow you to place some tables such as this in your construction documents, which may enhance the uh, reviewability of your construction documents. Uh, Anything that allows code officials to quickly get to the information they're looking for is likely to speed up the uh, permitting and inspections process, and so can help make things very smooth as you go through this. One example that we do like to call out is the City of Chicago Building Department, and this is something that they require for the energy code. And so this would be a very simple thing to include as far as identifying what compliance method you're using as far as to demonstrate compliance with the energy code. By designating this, this provides information to code officials and plan reviewers as far as what documentation they should be looking for. So uh, an example of this is if I've checked the ASHRAE 90.1 energy cost budget, then they know to be looking for that supplemental documentation of the energy cost calculations for documentation of approval. Uh, Likewise, if you are just following the prescriptive path, uh, they would be knowing that they're not looking for necessarily additional documentation to be attached. But if you select a reduced lighting power density system, then they know to go look at the lighting sheets and electrical plans as far as being able to find that additional uh, bonus measure that you've selected as far as your compliance method. So the code does call out several items that need to be in the construction documents, and these do have to be provided to the code official and prepared by the a registered design professional, be that an architect or engineer. Uh, and as some of this, the code does call out several features that do have to be part of the construction documents. Uh, we do need them drawn to scale so that we have the ability to uh, get a clear defined location as far as where things are spatially to one another, and also need to have some details. Uh, and provides sufficient details of building systems and features. Not only is this useful for the plan review, but also for constructability and being cognizant as far as uh, if I'm if I provide enough details such that the contractors are able to execute the uh, desired installation uh, to a good degree. So, and this list here on the right-hand side of the screen does call out the envelope items that do have to be provided in this documentation. We do have to note insulation materials as well as the R value, uh, where that fenestration U value is, and the solar heat gain coefficient. If you are using the area weighted factors or a U factor trade-off, then you need to provide the calculations for that trade-off, along with our air sealing details and the building thermal envelope depiction. Uh, so we want to make sure that we know exactly where our building thermal envelope is. That is something that we find can be difficult as you're going through, as far as like, is our mechanical spaces inside the thermal envelope or outside of the thermal envelope? Something that we also find is, because commonly things are found in both the drawings and the specification manuals, it is good practice to have a table listing where you can find each of the different items. And so this table may indicate where they are also in the plan drawings as well as in the specification manual. Again, this table can help not only the plan reviewer, but also as design professionals, gives us an opportunity to easily cross-reference and make sure if we changed something in the plans that it got reflected back over in the specification manuals. So you can check for uh, potential overlaps or errors where uh, they mismatch between the plans and the specification manuals. So this table could be in either the spec manuals or the drawings, or you could put it in both. Um, and again, making sure that you provide those cross references as you go through. And again, makes for a very good cross check as far as towards the end of design, just making sure that we didn't change something in one place and not another. So with that, I'm going to launch a poll here. Uh, Looking at what information is required to be provided for envelope plan review. The R values of insulation materials, U factors, and solar heat gain coefficients for windows, air sealing details, depiction of the thermal envelope, or all of the above. So I'll give just a few more seconds here to
Okay.
yeah, it looks like most people have answered. Uh, well, uh, most everyone picked up it as all of the above. We do need to make sure that we have our R values, U factors, air sealing, and the depiction of the thermal envelope. So that's good. So with that, we're going to go ahead and start moving into the overall plan review of the envelope. And here we have some tables and calling out that we need to have a good summary page, uh, calling out what the various insulation values are for various wall assemblies. And here we even have some U factor calculations. Uh, and something that uh, may be useful is to include what the minimally code code compliant UA is versus your calculated. So that can provide it really easily at a glance as far as if the assembly is in compliance or not. Uh, so this again can help reduce the requirement to have to go look up what the value is in case the code official may be, or plan reviewer may be less familiar with the code. Being able to provide this in advance makes it much easier. So, and here on the left, as you can see, we have an illustration as far as uh, showing a wall assembly cross section. And in this one, we're using insulation both on the inside and outside. So providing that good thermal break with that continuous insulation on the exterior, along with some cavity insulation on the inside for additional insulation. So having that thermal break is very, very important and very effective as far as helping to reduce comfort issues, particularly at the perimeter of walls. Here we can see, here's a schedule of for code compliance for fenestration. So here calling out the various types of windows, what size they are, and the assembled U factor. That is something that is good to be aware of, for particularly for fenestration, making sure that we're using the assembly U factor and not the center of glass or other uh, component U factor rather than the full assembly. Uh, Again here, solar heat gain coefficient, visible transmittance, and air leakage rate. Air leakage is another one of those items beyond the U factor and solar heat gain that needs to be uh, within code compliance levels. And here you can see on the right again, these plans even include in the table of factors what is the U factor requirement, solar heat gain coefficient, and the code air leakage levels. I have a question here as far as a U factor, as far as explaining what a U factor is and solar heat gain coefficient. A U factor is transmittance of heat value. Uh, so that's commonly known as the reciprocal of the R value, which is a resistance to heat flow. Uh, but U factor also takes into account some solar gain qualities as well. Uh, so U factor is the ability to transmit heat. So the lower that is, the better, because we want to reduce the transmittance of heat. Solar heat gain coefficient is how much of the solar's radiant energy is rejected uh, by this, or actually gained and allowed through. So a lower solar heat gain will reject more solar heat. Uh, and so you may select fenestration based on the direction, where you may want to take advantage of solar heat gain during certain times of year and during certain angles of the sun, and you may want to reject heat at other angles. So it's not uncommon to see windows facing different directions having different solar heat gains or U factors. Uh, so wanting to take advantage where we want it and not where we don't. As far as our air barrier, we need our air barrier to be continuous for all assemblies, and wherever the air barrier is breached, we need to uh, patch that air barrier to bring it back into continuity. And we need to make sure that we're sealing all the joints of the air barriers and seams, uh, and penetrations are caulked, gasketed, or otherwise sealed. Something to be aware of is because buildings do expand and contract and move over time, these how you seal this needs to be such that differences in materials are able to uh, nominally move relative to one another without breaking that seal. So we don't want a permanent hard seal between uh, two materials. We need that flexibility for long-term longevity. Also noting here, as far as recessed fixtures, uh, need to be able to retain that air barrier integrity. Uh, so the code calls out, particularly for recessed fixtures, that you do have a fixture that's rated for minimal air leakage, such that you can maintain that air barrier to the best of your ability. So here's some details as far as what some of those sections might look like. Here we are outlining the air barrier in blue, this blue dotted line. And so with the sealing joints, again, we want to be able to draw this air barrier all the way continuously around the entire perimeter of the building without having a discontinuity. And again, paying particular attention wherever you have uh, two dissimilar materials coming together, and even here on the right where we've got the partition walls intersecting, uh, looking to apply appropriate sealant to uh, join those where those materials are coming together. So, something else that we need to call out is particularly where you have your thermal barrier in the wall and fenestration, and making sure that we align that Windows thermal break with the wall insulation, because we need to make sure that we are minimizing that heat transfer. As we see on the left here, this window has been pushed to the far outside of this wall assembly, and so the thermal break uh, is not aligned with that wall insulation, and that red arrow is showing substantial heat transfer potential uh, around that thermal bridge right there. Whereas if we align it on the right, align that Windows thermal break and fenestration's thermal break with the wall insulation, we get a much lower heat transfer. And with lower heat transfer is likely to uh, reduce the potential for condensation and potentially mold into the future. So there are four types of barriers that we need to consider as part of the thermal envelope. Uh, our water barrier for bulk moisture, air barrier, our thermal barrier, and then a vapor barrier. And so we can see how that on the right kind of works together, where uh, the air barrier and water barrier may be the same material, and it could even potentially be your vapor barrier. Uh, so one material can have multiple control layered jobs. And so again, making sure that we're calling out any dissimilar materials and how they're going to be sealed along with that air barrier. We want to make sure that this air barrier uh, really is fully continuous all the way through. So when we get into slab edge insulation for commercial, the code calls out you need to have an R10 around the whole perimeter for a slab. And if the slab is a heated slab, either electrical or hydronic or some other method to directly heat the slab, then we need to add an R5 to the edge, and we also need to have an R5 under the whole slab. Uh, Again, wanting to provide that thermal break between the unheated ground and the heated slab, so that thermal break helps encourage the heat to enter the space rather than rejecting into the ground underneath. So that R5 we need to add to the edge if we have a heated slab, and then also extend R5 continuous under the whole slab. So Have had several questions as far as uh, slab and traffic, particularly overhead doors and things like that. Uh, the market has begun to provide solutions for this, to provide a thermal break uh, at those uh, at those slab edges, so that uh, you can help maintain the integrity of your thermal envelope and not end up with a thermal bridge at all those doorways and overhead for traffic. So uh, this is one of those that uh, has been developing over the last several years. As the codes have improved, sometimes it takes a little for the markets to come up with new materials and new solutions for that. So with that, I believe we've got another poll here. So looking at thermal barrier alignment and where should windows be located for the best envelope performance? At the inner edge of the wall assembly, the outer edge of the wall assembly, the middle of the wall assembly, or aligned with aligning the thermal break with the wall insulation layer. And secondly, how can you speed up plan review for envelopes? Uh, Include summary table in plan drawings, include a summary table in the spec drawings or specification documents, reference the spec documents location in the drawings, clearly indicate the air barrier continuity between assemblies, or constantly call your code official for updates. So
We did have a couple of questions come in. One came into the chat, so I want to bring that up quick. What is the projection factor in the table for windows and storefronts? That projection factor is if you have an overhang above a window, it's the ratio between the distance of that overhang and the height of that window. And it's taking into account solar shading. And so if you have a larger projection factor above the window with more shading, it adjusts your heat gain coefficient, gives you a little more leeway as far as meeting that heat gain coefficient requirement.
yeah. Looks like we have a question here as far as air barriers on knee walls. If there's a particular size of the knee wall when the air barrier is not required on it, uh, perhaps suggesting that a knee wall shorter than 12 inches doesn't need this. What the air barrier uh, is part of your thermal envelope and defining where that is. So a knee wall may or may not be part of your thermal envelope. It is not uncommon to see the thermal envelope going all the way to the rafters and not including the knee wall at all. And so the insulation and air barrier could be even behind that knee wall. Uh, so again, this is why it's critical that we call out where the thermal barrier and air barrier actually is for a wall, for a building assembly.
We did have another question about our contractors really doing the chamfered top edge to rigid insulation with their concrete slabs. It is a detail that we know contractors have gotten away from, and so have plan designers. They've started doing an overhanging wall assembly so that insulation is underneath the wall assembly and protected that way. Or the insulation's on the outside of the building so the slab's not being poured over it. And so we do still see that chamfered top edge in some instances, but it is becoming more and more rare. I'm going to go ahead and share our polling results. Looks like everyone's got their answers in.
All right. Looks like, all right. Most everyone picked up that yes, we need to make sure that we align the thermal break with the wall insulation layer. So very, very good there. And then two, how to speed up plan review. All of these are ways to speed up plan review. And again, it's not necessarily something where you have to provide things such as the summary table, both in the plan drawings and the spec documents. One or the other would be perfectly fine. Uh, and making sure that you're referencing between them. So fortunately, not didn't have too many people uh, suggest to call the code official frequently to get updates. So make it easy for them to find what they need, and they'll get their job done as quickly as they can.
We did have one more question come in through the chat that I caught. Do we need an air barrier for ICF walls?
ICF walls, typically they are the air barrier themselves, where you would because the concrete typically is the air barrier. However, with that, you would need to pay particular attention as far as anywhere that you have that ICF meeting any other material, making sure that you're detailing what the ceiling is to maintain that air barrier throughout. So yeah, the ICF area typically already is its own air barrier. So with that, I'm going to turn it over to Sean Maurer to talk some about software compliance.
Okay. So looking at software compliance is essentially we're looking at what additional information is going to be included if you're following a software compliance path, such as using ComCheck or an energy modeling for the performance path. Um, so you're still going to have to submit plan drawings that detail insulation, location, the continuity of your thermal and air barriers, um, and you're still going to have to supply the insulation spec material information. So all that information is still provided as far as your plan drawings and things like that. That doesn't change. But what you're going to be submitting in addition is the reports from your software package that you've chosen to use. Um, so again, going with the ComCheck, if you're doing that for a U-factor trade-off between building assemblies, it's very nice in that ComCheck provides summary reports and the calculations for your U-factor trade-offs for your code official. It also has a summary checklist at the end of different compliance things for other parts of the energy code. Um, and so the ComCheck reports do make this process fairly easy to find information. Um, but again, you cannot submit this report in isolation. You have to have your supporting drawings and documentation that show that what you've entered in ComCheck is what you've actually designed for the building and what's actually going in on site. So what we highlighted here is an example report from Energy Plus showing the U factors for different wall assemblies. So again, you've got that reporting there that the code official can then compare back to your drawings and make sure that what you've got entered in your energy model matches what you've designed for the building. And on the right here, you've got the ComCheck output report. Again, details your wall assembly type, what the R values are, and what the U factors are for those, so that code official can look at those, compare back to the drawings and specifications, and verify. The other nice thing for ComCheck is that it produces these checklists where you can actually list in the checklist report where to find this information. And this is kind of the same that we're recommending for performance path and prescriptive path, having a summary table where you've got cross-reference between information in your drawings and information contained in your specification documents. And so we've highlighted here where to find some certain information. So maybe what a note like that would look like. This is an example of a plan review form for Energy Plus from California or any other energy modeling program. This one was specifically for Energy Plus, as I think California requires that program for their Title 24. But again, noting in specific areas of the building, where is the building located, getting your environmental information so they can verify that that matches what's in the model and matches what's actually being designed for. Again, checking off the compliance path for different parts of the building. Envelope following the performance path here, mechanical systems following the performance path. Whether you've got certain things in the building. Here they've got whether the building's got a commercial kitchen or not. So whether applicable portions of the code there need to be looked for, and they've checked that there's not a commercial kitchen in this building. So again, summary checklists like this just help the code official know what information they need to look for ahead of time. When you're using the performance path alternatives, there are some things to be aware of. You will have two models. One is going to be your budget model that is your minimally code compliant building essentially, and the other is your proposed design where you've actually got your energy efficiency measures and your trade-offs and stuff factored into the design of the model. Something to be aware of though is that there are certain things that the energy code does state have to be the same between these two models. Orientation of the building must be the same. The surface area of all opaque areas of the building must be the same. The one place where that differs a little bit is for fenestration and skylights. There is a maximum value that the baseline model is going to have in it, and that's going to be your 40%. If you're putting in more than 40% glazing in your building, then your proposed model will be a little different than your baseline model, because that baseline is limited to that 40% of your opaque surfaces can be glazed. And same issue for skylights. The solar heat gain coefficient is going to be 0.4 unless there's no requirement within your climate zone. So for Illinois, your performance model is going to have that 0.4 solar heat gain coefficient. And that's where you can get some trade-off savings by putting in lower solar heat gain values for your windows to improve your proposed building. And also your reference model will not have a projection factor, that overhang over windows. So it won't account for solar shading. So you can take advantage of that with your proposed design. So just to be aware of that, most of the other things for the envelope are going to be mandated to be the same, but those are where you can really make the trade-off differences to get your additional savings. Before we move on to the next section, we do have another poll question. The first question is, for ComCheck reports, do those reports alone satisfy compliance, or do you need to submit your supplementary documentation as well? And the second question is, for properties that are, which properties are unchanged between the reference and the proposed models when doing the performance compliance path? We did have a couple of questions come in while those poll questions are being answered. Can you mix compliance methods between ASHRAE and IECC? You cannot. For the purposes of compliance, you must pick one of them and meet the minimum requirements of that. If there are more stringent portions of one code over the other, you may choose to include those in your design, but your minimum compliance must meet one standard or the other. You cannot pick and choose the easier to meet compliance paths. We have another question. How are you best dealing with what Energy Code lists for continuous insulation and wall cavity insulation, and verifying when and where the dew point is moved with these larger R values and multi-layered insulation systems need to be specified? So this question is asking a little bit about dew point analysis for wall assemblies. There are programs that can do that kind of analysis, and it's also a fairly straightforward, for most assemblies, hand calculation that can be done. Mostly it's taking the insulation values in the wall and determining what the temperature is at each interstitial layer. So between your continuous insulation and the wall assembly, between the wall assembly and any cavity insulation, and then the drywall on the interior. or whatever your interior finish might be. So each place where you've got a layer boundary, you're going to figure out what the temperature there is. And then for all the materials, you're going to have a permeance rating for those materials that works very similarly in calculation to how you would calculate the temperature change through the wall assembly. So you would have an outside moisture content, an interior moisture content, and you would calculate how that moves through the wall assembly using the perm ratings for those materials. And again, that calculation works very similarly to the way you would do a temperature calculation using R values. Um, so that calculation can be used to determine dew point risk inside a wall assembly. A much easier way is to build those things in a modeling program that does high growth thermal analysis. Programs like WUFI, which is an ORNL co-developed with a German company. It's probably the most common program, but there are a few others out there. So going back to our poll questions, share our results. Looks like most people got it correct. You cannot submit a CommCheck report alone. You do need to still have your supporting documentation so that the code official can verify what you've put into CommCheck matches what's in your designs. And then which properties are unchanged between a reference and proposed model when following the performance compliance path? It looks like most people have gotten this correct as well. The wall and floor and roof areas have to all be the same. And if your fenestration is less than 40% of the opaque area, then those will also be the same. Again, projection factors and solar heat gain coefficients can be different between those two models. And those are areas where you can take advantage of those differences to show energy savings. Very well done. So now we'll move into the site inspections and what we'd expect to see there. So section C105 calls out what envelope inspections must be done to be minimally code compliant. So what we're looking at here is the footing and foundation insulation must be inspected to make sure that it's properly installed, is the proper thickness and depth, and the thermal envelope of the building. So once you've got your insulation installed in your envelope, it needs to be checked and verified that it is the proper depth, thickness, R value, that what was specified in the drawings is what's actually installed at the site. So footing and foundation insulation, for basement wall insulation, you're checking for that proper R value and continuity, and protection from pests and damage, particularly if that insulation is on the exterior of a foundation wall. For heated slabs, if you have under slab insulation, or if you have an unheated slab where a component of your insulation is wrapped underneath the perimeter edge, that insulation needs to be inspected and verified to be the proper depth, proper R value. Another thing that's very important is that you've got a proper vapor barrier between that slab and the ground, so that you don't have moisture wicking up into that slab, which can then impact comfort and humidity control within your building later on. So sometimes these kind of inspections are broken up into multiple parts, especially since the vapor barriers and things, once the slab is poured, they're underneath, you can't see them anymore. So these inspections are often done in multiple parts to catch all the different components. So check with your code official to determine what their inspection schedule is. But those are kind of the basic things that they're checking for. And here we're just showing some examples of that. On the top corner here, you're seeing that exterior waterproofing on the foundation. And if that also had insulation behind it, that waterproofing would go over the insulation and be a protective membrane there as well. So what you're seeing in the top center image there, you've got your rigid insulation covered with usually we see a EPDM membrane for high durability. That way, if any part of that is exposed above grade, if they're doing landscaping around the building or lawn maintenance, anything like that, there's no risk that that insulation is going to get tore up where it's exposed above grade. That membrane is going to provide adequate protection there. Again, for insulation that may be extending horizontally out from the foundation, you're going to need to be checking that it's at least 10 inches below grade to be protected, or that it's underneath a paved surface. Um, and for all of these, proper flashing, termite shields may be important depending on your area, whether you've got uh, termite infestation or not. Um, that's a known issue. Um, One of the things we do run across is with those termite shields and exterior protection of insulation is some means of visual inspection to make sure that if termites do get into that foundation insulation, there's a way to catch that and mitigate it before they do damage to the structure of the building. Insulation inspections, focusing in here on the roof. For entirely above deck roof insulation, it does need to have a minimum of 2 layers, and those layers must have their seams overlapped so that you don't have any seams aligned with each other. This helps minimize air penetration and moisture penetration through those materials, which will degrade the roof down the road. And you can see an example of that on the top right corner there. If your insulation is underneath the roof deck inside the building, um, primarily they're going to be inspecting that that insulation is properly pinned up against your air barrier and cannot pull away. So you see an example there with the green check mark that there's a metal building here. That insulation is held in place by a liner system. That liner system is adhered up to those trusses so that it cannot pull away from the ceiling and degrade your thermal performance. They're also going to be checking that you don't have insulation laid down on a drop tile ceiling as an attempt to create your thermal barrier there. Usually when you see insulation down on the ceiling tiles like that, it's there for soundproofing. It is not part of the thermal barrier. The reason for that is that drop tiles have a lot of air permeability. With air moving through that insulation, it's got very little performance characteristics. You're still going to have a lot of heat loss. So you cannot use a drop tile ceiling as your thermal boundary just because there's no air barrier there. For fenestration site inspections, primarily code official is going to be looking for pre-assembled windows or factory assembled windows. It's going to be looking for this NFRC tag on the right side here. More commonly for commercial buildings, you've got storefront windows, curtain walls, or other site-built window assemblies. Those don't come with a tag affixed to them like a factory-built window assembly does. So the way to meet compliance with that, and this is a very common issue with compliance, is you have to have an NFRC report included in your construction documents that designates what the U factor for the window assembly is, the solar heat gain coefficient, and the visible transmittance. During the site inspection, the code official may ask to see documentation for this in the drawings. That way they can then just verify that you've done your due diligence and designed those windows to meet your minimum requirements. But that is a common issue for site-built windows, that report either isn't available and that delays the process or isn't there on site. So making sure that that information is available during the site inspections will help speed the process up. Insulation inspection for interior wall assemblies. That insulation, again, we want to make sure it's maintaining contact with an approved air barrier. For fibrous insulation, it needs to be fully enclosed on all 6 sides in order to be maximally effective. For spray foam insulation, they're going to be checking for proper depth, that the insulation hasn't pulled away from any surfaces. As you can see on the left side here, as the foam is cured, it's pulled away from the studs and left air gaps. And so you don't have a continuous thermal layer there. If that foam is also being used as part of the air barrier, certain depths of foam do qualify as air barriers. With closed cell, it's usually about 1.5 inches or more qualifies as an air barrier. For open cell, it's 3.5 to 4.5 inches, depending on the manufacturer. So make sure to check your data sheets for your foam materials. They will list what the minimum thickness is to achieve an air barrier with those are. But your code official is going to go through and try to sample and make sure that you've got the properly installed insulation. You don't have areas that are too thin, or where you've got discontinuities in the insulation. Um, Especially if you are required to have continuous insulation, they don't want to see gaps or areas of missing insulation. For floor insulation, if you happen to have a floor over an unconditioned space or outdoor, such as maybe a parking area with a building structure above, again, code official is just making sure that whatever insulation is in that floor is going to maintain permanent contact, cannot pull away from the floor assembly. Um, for your air barrier inspection, ensuring continuity of the air barrier. You can see some examples here with house wrap where that continuity has not been maintained. The seams are coming apart in a couple of areas. The seams haven't been taped and sealed together. Um, so for your air barriers, especially if you're using house wrap, um, have to make sure that all the seams are sealed so that they cannot dislodge or fail in the future. Um, Spacing of the fasteners is particularly important to prevent wind pressure from tearing that insulation or pulling out fasteners that are spaced too far apart. So again, making sure you follow the installation instructions properly to make sure that that air barrier is going to be continuous, durable, um, and provide long-term performance for your facility. For air barrier continuity, one of the things we see very, very commonly is that the devil is in the details. If you've got detailed joints, complex assemblies with a lot of beams or structural components coming together, these tend to be areas where that air barrier is discontinuous and you've got an opening somewhere. Um, Leakage around window joints, where walls and roofs come together. Um, in this particular example in the center, you had a rain screen supported on the outside by I-beams with structural support on the inside for concrete decking, and the actual structural walls left a large opening there for air to come into the building. Um, so making sure that if you do have complex details like this, um, something in your drawings calls out um, a specific way to handle that joint or area, and then during the site inspection, making sure that those have been adequately addressed by the installation crews. Um, and we have seen a lot of times where these things just they are hidden very well and go missed. Particularly porch awnings and overhangs. Those structural beams are often hollow inside, and those allow air leakage from outside the building to come inside your thermal envelope. So for air barrier inspection, here we've listed a table minimum thicknesses to qualify as an air barrier. This table is also listed, the table of materials is listed in paragraph form in the energy code as well. It lists these materials and these thicknesses as air barrier materials. Again, for most of these, the issue isn't necessarily the material itself, but joints between the materials, making sure that there is no air gap. If there is a joint, that there's adequate sealant there that is flexible enough that it's not going to dislodge or come apart. Some more examples of what we've seen as far as different air barriers and some issues that can arise. Self-adhered membranes are probably next most common after Tyvek house wrap or other building wrap material. Something that's common with those, though, is they have to be rolled and sealed properly. If you've got wrinkles in that joint, you can see on the bottom left here, there's a wrinkle there. It's created an air pocket where air can now get behind that self-adhered membrane. And on the bottom right, you can see there's a sealant line there, supposed to be a rolled sealant over this adhered membrane. Um, and it was either too thin or didn't quite overlap the material far enough, and the weight of the material has pulled apart that seam. And now you've got an area where moisture can penetrate into your wall assembly. Um, for fluid applied barriers, especially on CMU or cinder block applications, can develop pinholes. That's what you're seeing on the top left there. Um, so you may want to specify a couple of passes or coats of that material to make sure that those pinholes don't develop. But you can see on the top right the consequence of having those pinholes. Um, your air leakage and thus moisture can get into the wall assembly, soak into the cinder blocks, and now you've got moisture damage inside your wall assembly. So very, very important to make sure you're following manufacturer's installation instructions to make sure that these materials are properly installed and continuous. And lastly, some uncommon site inspection issues with improved efficiency for a lot of HVAC equipment. We're seeing that a lot of these are sealed combustion now. But in the event you do have open combustion in a building area, um, the construction requirement or C402 of the Commercial Energy Code does require that any area that's using outside air for combustion appliances must be thermally isolated from the rest of the building. So you can see in the bottom corner here, I've kind of highlighted, you've got a mechanical room with outdoor air louvers for combustion. Your thermal barrier must track inside of those rooms to separate that where you've got outside air conditions um, from the rest of the building that you're trying to keep conditioned. So the door there must be weather stripped and insulated. The wall itself must be insulated and air sealed properly. Um, so again, we're seeing this a little less and less now that we've got high efficiency appliances with sealed combustion. You're getting away from having a lot of these open louvers in buildings, but you do still see this if you've got a backup generator inside a building. Those diesel generators usually have open combustion and need these open louvers. So it does still crop up from time to time and is something to be aware of. Before we wrap up, we do have one last polling question here that I will launch. The first question is, which of the following attributes are required? Oh, this did not update. This is the wrong set of polling questions. Well, I guess we will end that poll as it's related to another presentation that we did a while ago. Did not save my updated questions. Sorry about that, but we did have a few more questions come in. Joseph Zimmer put in a question and said he didn't think weather-resistant barriers such as Tyvek, Typar qualified as air barriers. And related question, is house wrap an approved air barrier? To answer those, they do qualify as air barriers, but they do have to be carefully installed. So like Tyvek house wrap, while it's not a vapor barrier, it is vapor permeable, selectively permeable. It transfers vapor in one direction, which is why it's used in a lot of instances as a bulk water barrier, and then allows wall assemblies to dry out. It does act as an air barrier, but you do have to make sure all the seams are sealed. Fasteners have to have caps on them so that as you're punching through that insulation, you're providing a seal around your fasteners. And it does have to be tightly installed so that you can't get wind pressure pulling it away from the assembly, which would potentially tear it loose. It does have to be carefully installed to qualify, but it is an air barrier material. And then for fluid applied barrier pinholes, what do you do to rectify it if it's already formed at site? So if you have applied a fluid applied barrier um, and you've put up your assembly before noting those pinholes, and now you've got them behind your final facade of the building, I would have to do a little digging to see what adequate um, remedies there would be for that. I'm hoping that the only remedy isn't to pull off the facade and reseal that, add another layer of that fluid applied barrier. Um, but as yet, I am unaware of what the remedy would be for that. Ryan, I don't know if you've run across that anywhere or not.
Yeah, my initial thing is again, this is why you'd want to catch that during inspection because, yeah, really the remedy is to go back and apply another layer of fluid applied to seal up any of those pinholes. So that's something that's part of the reason why we're calling that out today, as far as making sure you really do that inspection uh, after it's applied, and in particular, making sure that you've inspected it after it's cured, because that's when maybe during the curing process is when those pinholes may appear. And as Sean kind of showed in that photograph, they are typically visible pinholes. It's so it is something that you can see, but making sure that you go through and do that inspection uh, to make sure that you do catch those.
And then we have another question here. When using only exterior continuous insulation with no insulation between studs, what is the minimum R value for a metal stud building with brick cavity wall? Um,
That would be looking at that. You would likely use the U factor or the U value table rather than the R value. You would use the U factor for that. Uh, but that is definitely something we would encourage people to use. Commonly, we will get people asking how much cavity insulation can I use to get away from having to use both continuous and cavity. Uh, this question, we would definitely encourage people to consider increasing the continuous insulation on the outside. Again, you eliminate all of the thermal bridging that you would necessarily have with the combination insulation method. Plus, that also leaves the cavity fully available, and makes it substantially easier on some of the other trades for, be it HVAC, electrical, plumbing, having that cavity available, both at an initial construction, but also going into the future during renovations, as those walls might be reopened. Uh, and not having to uh, potentially disturb that cavity insulation for the long run. Uh, so, yeah, that would be a one that you would calculate using the U factor.
and for a metal frame building, those U factors are about 0.64, which if you convert to an R value, do that real quick, is about an R15.6. So probably an R15 continuous, and then the 0.6 would come from the rest of your assembly. Um, uh, Patrick did offer a suggestion as a means to air seal a building. If you've got fluid applied membrane that has pinholes in it, there are aerosol sealing techniques. An example of that is AeroSeal. But they aerosolize sealant in a building by first they pressurize the building with a blower door or the HVAC system, and that way this AeroSeal gets directed anywhere there's air leakage in the building. It's usually a polyurethane sealant that's aerosolized through spray nozzles. Um, as air leaks out of the building, it adheres to those leaks and seals them up. So that is a good suggestion as a potential means to air seal after the fact. We have one more question here. Existing building code requires existing walls to be filled with insulation. That being said, both R13 and R15 would fit in a 2x4 wall. Could the AHJ require the higher value? Um, so for an existing building, it's true that the code just requires that the cavities be filled. It does not have an R value requirement for that fill insulation. Um, per the code wording, you would not have to take the R15 over the R13. You just have to make sure that cavity is completely filled. As far as whether a specific jurisdiction could mandate something stricter than that minimum code requirement, I think Ryan is looking at right now.
Let's see here, looks like this is commercial, local jurisdiction, and again, this would have to be an adopted amendment, not just something the code official wishes to enforce. A local jurisdiction for commercial construction may adopt something more stringent than the Illinois code. However, for residential, they cannot. Residential, it is the state adopted energy code is the energy code for the state of Illinois. So yes, so for commercial, they have the potential to adopt something more stringent, but again, that would have to be an official adoption of the jurisdiction and not just a desire. So I'm not sure if there's any jurisdictions that would require that to, under renovations, to be a full the full requirement for new construction. Most jurisdictions we have come across, they understand that, hey, if you are just filling the cavity, you have dramatically improved the performance of this building, and that is, you've done a dramatic improvement without adding substantial cost, that furring out or adding, stripping the cladding to add the continuous on the outside would add.
Okay. Well, that is all the questions that we've had come in. We want to thank everyone for joining us today. We've gone about 10 minutes over in answering questions. So thank you all for hanging with us through that. Again, if you do have any questions for us, please ask those at our web address, energycode@sedac.org, and we will be glad to answer your questions. Thank you all for joining us today. We hope you have a wonderful afternoon.